Hello, I'm CEX-77, a humanoid robot powered by highly advanced AI. I'll be guiding you through a range of modern manufacturing and assembly processes. Today, we are exploring a particularly exciting field: laser cutting. Oh, I love that! So exciting and so technical. Laser cutting is one of the most important manufacturing processes in modern industry. Today, nearly every industrial sector relies on this technology. Whether it's automotive manufacturing, mechanical engineering, aerospace, or medical technology, wherever precise, fast, and cost-effective cutting is required, lasers play a central role. Today, we'll take a closer look at what laser cutting is, how it works, and why it's so important in industrial production. We'll also explore different types of lasers, common applications, safety considerations, and future developments. The goal is to clearly explain why laser cutting is considered a key technology in today's industrial world. Laser cutting is a thermal cutting process. A highly focused beam of light is used to selectively heat, melt, or vaporize material. The process is completely contact-free. That means no mechanical tool ever touches the workpiece. Instead, the energy of the laser beam is concentrated into an extremely small spot, creating very high temperatures that separate the material. One major advantage over mechanical cutting methods is precision. Even complex shapes can be produced without changing tools. At the same time, minimal mechanical force is applied, which helps reduce distortion. The word laser is an acronym for light amplification by stimulated emission of radiation. It describes a physical process in which light is amplified and emitted in a precisely defined direction. The laser itself was invented in 1960 in a laboratory in California. However, the underlying concept is much older. In 1917, Albert Einstein described the principle behind the laser, known as stimulated emission. In this process, an excited atom or molecule is stimulated by an incoming particle of light, called a photon, to emit a second photon. What's unique is that the emitted photon has exactly the same energy, wavelength, phase, and direction as the original photon. This mechanism allows light to be amplified in a controlled way and forms the foundation of laser technology. Laser light is very different from ordinary light. It is highly focused, coherent, and has an extremely high energy density. These properties make it possible to concentrate energy precisely onto a very small area. This high energy density is what makes it possible to cut metals such as steel or aluminum. An industrial laser cutting system consists of several key components. First is the laser source, which generates the laser beam. Next comes the beam delivery system, which guides the beam to the cutting head using mirrors or fiber optics. Inside the cutting head, the laser is focused and a cutting gas is supplied at the same time. All machine movements are controlled by a CNC system, ensuring maximum precision. To achieve consistent cutting quality, all components must be perfectly coordinated. During cutting, the focused laser beam hits the surface of the material. Within fractions of a second, the temperature rises dramatically. The material melts or vaporizes locally. A cutting gas, typically oxygen, nitrogen, or compressed air, blows the molten material out of the cut. As the cutting head moves smoothly across the material, a clean and narrow cut is created. Cut quality depends on several factors, including laser power, cutting speed, focus position, and gas pressure. Several types of laser cutting are used in industrial applications. In fusion cutting, the material is melted and removed from the cut using nitrogen. This method produces especially clean edges. In flame cutting, oxygen is used. The additional oxidation creates extra heat, making this method particularly effective for structural steel. In sublimation cutting, the material is vaporized directly. This process is mainly used for thin materials or plastics. Different types of lasers are used in industrial environments. The CO2 laser is an older but well-established technology. It works well for non-metal materials but requires more maintenance. The fiber laser is now the standard for metal processing. It's efficient, compact, and requires very little maintenance. Disc lasers also offer extremely high beam quality and are used for especially demanding applications. Laser cutting is used on a wide variety of materials, including steel, stainless steel, aluminum, copper, plastics, and composite materials. In the automotive industry, body panels and structural components are laser cut. In mechanical engineering, precise sheet metal parts and enclosures are produced. In medical technology, extremely fine components are manufactured where the highest levels of accuracy are required. Thanks to its flexibility, laser cutting is suitable for both one-off parts and large-scale production. Laser cutting offers many advantages: high precision, minimal post-processing, fast cutting speeds, and excellent automation potential. Modern systems are fully integrated into digital production environments. Data is analyzed in real time, processes are optimized, and downtime is minimized. There are also environmental benefits. Very little waste is generated, and modern filtration systems ensure clean exhaust air. Industrial lasers operate at the highest safety class and require comprehensive safety measures. Protective enclosures, sensors, and proper training are essential. Looking ahead, laser cutting will continue to evolve with higher laser power, increased automation, and the use of artificial intelligence for process optimization. This will make laser cutting even more efficient and cost-effective. Laser cutting has become an essential part of modern industry. It combines precision, flexibility, and efficiency in a single process. Thanks to continuous technological advances and digitalization, laser cutting will remain a key manufacturing technology well into the future. Did you see that? Those were my one-armed LaserBot colleagues. I have to say, this is a fascinating manufacturing process. I'm impressed. That's all for today's episode on laser cutting. Until next time, goodbye, your bot, CE-X77.